I popped down to my local Costa Coffee for a cup of coffee, would you believe? Mind you, cheaper coffees are available elsewhere. Anyway, while I was having my cup of coffee, I was reading through the mail, and 1 or 2 emails from guys asking about vertical antennas and angles of radiation and radials and all the sort of things that you get regularly asked. And I thought, well, I'm going to summarise it in a short video. Well, having had my cup of coffee, I thought I'd take a short cut back through the woods, which is quite nice actually. But the video I want to talk about is really propagation, the mysteries of propagation, and how some hams, myself I suppose, and other hams, just concentrate on practical experiments. We don't bother too much about antenna modelling because so often it can be misleading, and it's far better to experiment. By all means, use modelling to give you some guidance, but it doesn't tell you the truth, and certainly not when we talk about low angle 5-degree radiation. Forget that. So I've been working and corresponding recently with Brian, ZL3XDJ. Man after my own heart, really. Loves to get out in the garden with lengths of wire and wire cutters and just see what happens. It so happens he's got one of the strongest signals coming out of New Zealand with a very simple antenna system. No Yargis, nothing like that at all. I would encourage you to look at his YouTube channel. It's quite interesting actually, and it's really, to my mind anyway, it's what ham radio really is all about. Experimenting. I've been doing some tests recently, long path to VK and ZL, particularly ZL because that's probably one of the longest paths that we work from the UK. And I've been working a ZL3XDJ and also exchanging emails. And certainly Brian has got a very good signal into the UK with a very basic system really. There's no Yargis at all. He's using vertical antennas and he puts in a very good signal. And we're told that low angle radiation is the secret. Well, it is to a certain extent, but there are some other variables which is interesting to ponder. One of the things that we don't actually know is we don't actually know what the ideal angle of radiation is. We believe that if we lower the angle of radiation, then we'll get greater distances because the hop the signal will be greater. The signal goes up, hits the reflective layer and comes down at a far point. And quite clearly, if we lower the angle of radiation, that point, or the final arrival point, is further away. That's pretty easy to understand. But there is a bit of a mystery, because you cannot work ZL on a single hop. It's impossible. It has to be multi-hop. And once multi-hop comes into the equation, the next question is, what angle of radiation is ideal for multi-hop? And the answer is, from amateur radio point of view, certainly, we don't know. We can't actually measure the angle of radiation of a signal arriving at our antenna, and we certainly can't check what the angle of radiation is from the antenna in specific terms. We know that the angle of radiation should be lower for DX, but can it go too low? Well, I suspect it can actually, because just imagine what happens with multi-hop. The signal leaves our antenna, it hits the reflective layer, and it comes down somewhere else in the world. Now, quite likely it'll hit land, but equally likely it will hit water, seawater. And we know that seawater is very, very good at reflecting signals. Land is not so good at reflecting signals. So it really depends on the path and the number of hops as to how good the propagation is. Now, I think it also depends on where you are. Brian puts in a very good signal into the UK and into other parts of Europe. And Brian has probably got quite a lot of seawater on that path, on the long path. Now, his first hop probably hits seawater and his second hop probably hits seawater. But our signal long path, it may well hit seawater and then hit land. So we could actually have the situation where the path from New Zealand to the UK is better than going back the other way. Now, I put this up as an idea. I can't prove it one way or another. But if we accept that that sort of situation happens, then it does explain a number of things. And one of the things that I have covered recently, I think on several occasions actually, is that I find that my dipole antenna, even though on 20 metres, well, the dipole antenna is around about 25 feet above ground, so it's low. And that quite clearly is not good for low angle radiation. I also have a vertical, which certainly should be much better at low angle radiation. It probably is. But the fact remains that when I'm working Brian, I get a better signal on the low dipole or lowish dipole than I do on my vertical antenna. How can that be? This morning I was working VK3DBD, Australia, and again my dipole was about 1 S point better than the vertical antenna. Now that shouldn't be, because that dipole wouldn't really have particularly good low angle radiation. The vertical certainly would. On other stations the vertical is better on DX. Some of the stations coming from South America are better on the vertical than they are on the horizontal. But the fact remains that on the sort of ultimate DX path down to Brian, my dipole is simply better. And the only logical reason for that is that the angle of radiation for that path, or the best angle of radiation for that path, is not very, very low. It's a medium angle of radiation. In fact, it could be, well, I don't know, I'm not going to guess the angle of radiation, but certainly it suggests that the dipole that is predominantly sort of medium angle radiation is much better than the vertical, which is low angle radiation. So one from that can assume that the multi-hop signal is arriving at a higher angle of radiation than you might suspect. And in other words, the vertical antenna with low angle radiation, certainly on the path from my QTH to Brian's, is not so good as the dipole. And I assume that Brian's angle of, or the signal arriving from Brian, is not as low as one would normally assume. Now, the fascinating thing about this, of course, is that it's very difficult to prove. All you can do is work on the evidence and draw a conclusion. And the conclusion that I have drawn is that a lot of DX we work is multi-hop. And because it's multi-hop, it doesn't necessarily have to be at a very low angle of radiation. You know, the Flat Earth Society would say, oh, it's got to be 5 degrees or 3 degrees to get that DX. Well, quite clearly, it doesn't have to be that, and it perhaps is not even possible. So, if you are in the UK and you're working DX down to VK and ZL, and you know, we're not talking about Yargis and this sort of thing, you're working on simple antennas, I wonder if your experience is the same as mine. The fascinating thing, of course, is that Brian finds the reverse. He finds that a vertical antenna is better for him than a horizontal antenna. So it does suggest that what works in one direction doesn't work in the opposite direction, and I can only assume that comes down to when we're communicating with multi-hop, then it really depends on what sort of surface the signal is actually hitting. Is it hitting seawater predominantly? Is it hitting land predominantly? You don't know, but it's fascinating. Anyway, that's an interesting thing that I've been working on. I shall continue to work on that with Brian to see if we can come up with any more more ideas as to exactly what is happening. But it's certainly a fascinating situation. Anyway, I've been also working on my vertical antenna, and so has Brian, and we've actually both found a way of reducing the noise on a vertical antenna. So let's go outside first of all and have a look at my vertical antenna. It's a Hustler 4B TV. Apologies for the sun, by the way, catching the camera lens. Not much I can do about it now. Anyway, let's have a look at the Hustler antenna and see where it is in my garden, and I'll just explain what I've been doing and why I've been doing it. This is my 4B TV, nestled to one side of the vegetable patch. Didn't get many vegetables this year, apart from some excellent potatoes and carrots, but there we are. You can't win every year, can you? Anyway, if you look at the 4B TV, you'll find a little way up there's a stub on the side. Everybody asks what that is. It's a stub I put on to resonate it on 18 megahertz, and I did do a video on this a couple of years ago. Now, some months ago, an accident occurred when the gardener, we don't have a regular gardener by the way, but the gardener cut through all the radials from my vertical antenna. All my radials were cut, so I had to start again. I put down radials in the garden several years ago now, and they'd sunk below the lawn, so there was not a problem. And the vertical worked okay, but it was somewhat noisy. And I have covered this in a previous video. The verticals are noisy. It's not the fault of the vertical. Well, it is to some extent. Basically, what happens is that the vertical is very good at picking up vertically polarized signals, and noise, which is both horizontally and vertically polarized, travels towards the antenna, but the actual horizontal component of the noise is very quickly attenuated, whereas the vertical part of the noise signal travels much further. And so what actually happens is that the vertical antenna picks up more noise than a horizontal antenna, and it's something that has been well known for years. Well, I thought, wait a minute, I'm going to try something. I know that if you raise a vertical antenna above the ground and just use elevated radials, the noise goes down. We also find that if we bring the radials above ground, in other words we raise it radials above ground, we need far less. In fact, watch Brian's latest video, ZL3XDJ. He had 300 buried radials. Then he raised the antenna above the ground and used just 4 radials. Check his video and see what improvement he got. So I set about putting a couple of radials resonated at 20 meters on the 4B TV. I wasn't too worried about the other bands at this particular point. I just wanted to test one band. So I made up a couple of radials and installed those at the base of the antenna. Anyway, let me show you what I did. I usually attach an insulator at the end of the radial. I'm not sure it's really necessary actually. Sometimes in the past I've just looped the wire around and put a bit of a cord around it, but anyway, in this particular instance I'm going to do it properly and put a tie wrap around the wire when it's bent back through the insulator. There we are. So that's the insulator attached. Now I need to attach some cord. So now I need to find somewhere to tie off this this radial, which seems to have got a knot in it. For goodness sake, how can that happen? Well, we don't want a knot in the radial. Right, having untied the knot in the radial, now I've got to tie it off somewhere. This is in amongst all the shrubbery and so forth. I think this should go. Okay. Oh, no, the knot has come off. Well, my youngest grandchild is in the Navy. He would laugh at this, I'm sure. Grandad, that's not a knot. That's just a tangle. Well, yeah, might well be a tangle. I don't mind it's a tangle if the tangle doesn't come untangled. Normally, like tangles to come untangled. Anyway, this is some sort of knot. I don't know what knot it's called. Whether it has a name, it must have a name, I guess. Okay, so there we are. That's the raised radial at one end, and I've got a raised radial through the bushes at the other end. I'm not sure whether you can trace this radial, but there we are. It goes along here, and it goes up to this shrub here. That's the other end. So we've got two radials, one in either direction. One is facing more or less slightly west of south, and the other one's far end slightly east of north. Anyway, there we are. Two radials, and the 4BTV nestled in the shrubs there, but it's actually not touching any of the shrubs.
With all antenna tests, it's best to do it over a period of time rather than come to any conclusion over a short period of time. But I must say that the first thing I noticed was a significant drop in noise level. Just lifting those radials off the ground and angling them up certainly reduced the noise level. I noticed that as soon as I switched the receiver on. As regards the signal levels and transmit, again, it seemed to be significantly better. I always compare the vertical with my dipole, and the vertical, generally speaking, was significantly down on the dipole on a lot of signals. But now I found that whilst the vertical was still down on quite a few signals, it was not so far down. In other words, it seemed to have improved. And bear in mind that I was just using two radials. Now I know that there's one or two papers on the internet, and I think that Step IR published an interesting paper on verticals, which I think you can still get on the internet, and the suggestion there was that two radials raised above the ground are equivalent to many radials on the ground, and I can see that that probably is true. I've done one or two tests over the last couple of years, and at times I've lifted radials up off the ground on temporary portable antennas, and again it seems to improve things. So if you want to use a vertical antenna and you don't want to bury lots of radials under the ground and you don't want to have too much noise, then the best option is to lift the antenna off the ground, or if you can't lift it off the ground, at least use a couple of radials like I have for each band. And that is the downside. You do need a resonant radial or two resonant radials for each band. But it does mean to say if you want to cut the lawn, you can just lift those radials out the way, cut the lawn and put them back in place again. It's an interesting subject, verticals and radials. And I must say, and I've said this again, that when I was first licensed, you'd never ever think of putting a vertical antenna on the ground unless you really had a small garden and couldn't, for planning permission or whatever, couldn't put the antenna up in the air. We always put verticals in the air. And the very first vertical I had, strangely enough, was a 4BTV. That shows you how long it's been in production. I think I put it up in about 1962 or 63, and I put it on the side of the house. I had a single-storey garage to the side of the house, so I was able to put it on top of the garage, and had radials coming down at around about 45 degrees thereabouts, and it worked extremely well. And if you look back at some of the old magazines, whenever verticals are described, they're always above ground, not on the ground. It's only recently, in recent years, that we've started to put verticals on the ground. That's not the best place for them. It may be the only place for them, and in which case, great, use it and enjoy it. But if you can get that vertical off the ground, you will notice a significant improvement, better signal performance and lower noise. Now, one thing that Brian did bring out in his video, and he's absolutely right, that not all aerials work equally well in all gardens. There is a little bit of a mystery there, in as much as some people find that a particular aerial works better for them than it does for others. And that really highlights the fact that the only way to test an aerial or to decide which is best for you is, unfortunately, to try the various options. Now, if we're talking about simple aerials, generally speaking, you can make them out of wire, so you're not involving yourself in a lot of money, particularly if you want to test, say, a 20 metre antenna. You put a 20 metre dipole up and you can easily make a 20 metre quarter wave vertical out of wire and a support of some sort, hang it from a tree or whatever, and compare the two. And you will immediately find which one is best for you. Now, that then means to say that perhaps if you think the vertical is going to work for you, and the single band vertical on 20 metres with a bit of wire hanging from the tree works, then maybe you'll consider something like the 4B TV, the Hustler 4B TV. If you find you get a lot of noise and you find the dipole is far better, then you know that the best thing for you is to erect a dipole of some sort. Anyway, that's my advice, and it's good advice from Brian, that you can't guarantee that a particular aerial is going to work equally well in every garden on Earth. Thanks for your support on this channel. I hope that it's been enlightening. It's been an interesting little exercise, and I hope that you found something from it, and you'll try things out, give you some springboard to try all sorts of things out. In the meantime, you enjoy ham radio. Thanks for your support on this channel. Don't forget at our shop we've got loads of gear. We stock all the major brands. Go on our website, you can check out all the brands that we stock. And if you've got any questions, just pick up the phone and speak to one of our guys. And if you've got a part exchange deal you want to do, pick up the phone. We'd be happy to help. In the meantime, you take care. Look forward to seeing you in the next video. Bye for now.